Hello, my name's Paul and I enjoy talking about technology in general and software development in particular. Today we're going to look at a common task in application development, which is containerizing or Dockerizing an application. This will simplify deploying to most cloud services and let us easily set up local deployments for testing. I'll be using one of the most common languages and frameworks in enterprise work, a Java Spring Boot application, and I'll be looking at 3 different approaches to containerize it. So let's jump in. Okay, so let's look at our first approach. So the first approach is one of the simplest ones, especially if you have Java experience already. So with this approach, we're simply using Gradle to build our Java source, our Java project into a jar file, which is the normal thing that Java developers do. And then we're adding to that process by creating a Docker file which copies that jar file into the Docker image and creates the path and relevant environment variables for that Docker image to run, as well as setting the entry point, of course. So let's see what that looks like in practice. Over here I have a simple Java Spring Boot project. Source code, it's a very small project. Source code is here, and we have a Gradle build which is used to build and create the jar file. And this Gradle build will create a single fat jar file, so with all the dependencies in a single file, so it can easily be deployed. Now we've added to this project this Docker file. Now this Docker file starts off with, as all Docker files do, with a from statement that specifies which base image we're using to build our image on top of. So we're using Eclipse Temarin 21, which is a base image which has an operating system. It has JDK and is fully set up for running Java compiling and running Java applications. We're setting some important environment variables like the Java home, the path variable, and I'm also setting the name of the jar file that we're going to be building so we can reference it, and also the path locally where we'll find that jar file. So it's in build libs. Build doesn't exist yet until you compile the application, but that's where it'll be. And we've created a app folder in the root of the image. We will be copying the jar file into that app folder, and we're setting that as the working directory. And finally, we're specifying the command entry point of the image for the container to run to be Java jar and then the name of the jar file. So now if I run this on its own, it won't work because it will not be able to find the jar file, and because the jar file doesn't exist yet. So we need to run Gradle build outside of Docker first to go off and build that jar file. So now we're running our Gradle build process here to create the jar file, and that's completed. And so now we have a build folder. And in build libs, we've created this jar file, which is the fat jar that contains all of the dependencies for this application. Okay, so now we can go ahead and run Docker to build the image. So here we're using Docker build command, and we're going to tag a new image as Java Spring Simple. And passing the current directory as the context, and run the Docker command, and that runs very quickly, but we've tagged that new image, and you can see Java Spring Simple latest is there, built 11 seconds ago, and so we can actually run that now. And so I'm going to run Java Spring Simple, and I'm going, because it's a Spring Boot application that runs on port 8080, I'm going to expose port 8080 from the container into port 8080 for my host machine. In fact, let's make it port 8081. So now we're running Docker, but you can see Spring is starting up because that's what happens when you run this jar. And internally within Docker, it's exposing this service on port 8080. But if I open Chrome, 8080, there shouldn't be anything running on 8080 at the moment. But on port 8081 on the host machine, we get our white label error page 404 because that's because there's nothing exposed on that path. But that's correctly running, and so we've Dockerized or containerized this application, and we've run it within our computer. So it's then possible to push that image to a container registry and deploy it to cloud services, which we won't be doing right now. Okay, so now we're going to look at option 2. We're going to use what's called a Docker multi-stage build. So once again, we will start with our Java source file, our Java source code. And of course, we need a Docker file as well. But in this case, the actual building of the jar file will be taking place within Docker. And so we will split our Docker file into 2 stages. We'll have one stage which has all of the build tools, the Java tools necessary to compile the Java source into a jar file. And we'll have a second stage which is usually optimized for size and security to run that jar file in production. And so what we're doing is we're creating the jar file in one container, and then we're copying only the thing that we need, the deliverable asset from the build stage image into the run stage image, and then the run stage image is our output, which remains with us, and we can go on and deploy that afterwards. So let's have a look and see what that looks like. So once again, we still have our Gradle build, and this time we have a different Docker file, which I've called Docker build, just to differentiate it. And there are 2 from statements in this, so each is a different stage. So the first stage, which we're naming app build, is coming from Eclipse Temurin, and in this stage we're setting similar environment variables as before, but what we're doing is we're having copied our project, so dot, into the /source folder. We're changing directory into that source folder, and then we're running list just as debug actually, and then we're running Gradle W, so Gradle wrapper, to build the application. So this could be more efficient because Gradle W or Gradle wrapper will need to download Gradle, which is a little bit inefficient, but for the purposes of this demonstration, I haven't put in all the optimizations I could. So after having successfully built the project, we've now got a second stage, which is not based on Eclipse Temurin. It's based on Debian, and we set up similar variables again. And this time we're going to copy the JDK from Eclipse Temurin. So that's set up so that we can run Java. And then we're making a folder called opt app, and then we're copying from the app build image, which we named up here, we're copying the jar file that we just compiled, and we're putting it in our opt-app application folder. Then we're changing our directory to that folder, running a little bit of debug again, and then we're setting the entry point as being Java jar, and then this name here. Actually, we can optimize this by reusing these two environment variables up here, but that needs to change the syntax from an array into just a string, so I won't do it right now. Okay, so let's build this this image. So this is Docker build. We're not using the standard Docker file name, so we need to reference the file name with the -f option. We're tagging it as Java Spring Multistage and passing the current folder as the context. First time it's run, it will download Gradle, and a clear optimization is to embed Gradle into the base image so that it doesn't need to do this. Okay, there we have a successful build of the application, and now it's moving into the second stage where it moves the jar file into the Debian based image and tags it as Spring Multistage, Java Spring Multistage latest. If we look at the images we have, there it is. Let's go ahead and run this one. And this time we'll run it on port 8082. Okay, that's running. If we go over to port 8082, we have our 404 page from that service. Okay, let's just examine the trade-offs. So we took the Docker multi-stage build approach. So the advantages of this is that it's repeatable anywhere. So you don't need to have even Java installed on your machine because Docker sets that up. So there's no special setup other than having Docker. The disadvantage is there are more steps running in the Docker, within Docker. And so it can be a little bit hard to debug when Docker is not as transparent as running in your own terminal. And so when things go wrong and you have a more complicated build process, it's just a little bit more time consuming to debug it. As we can see from that, it's quite a slow build process. Since we downloaded Gradle, so you need to take extra care to make sure that your layers are, your image layers are configured so that all the time-consuming parts of the build are put into the earlier layers, so that they don't need to be re-triggered whenever you make a code change. So that takes a little bit more care. But otherwise, this approach is pretty solid, especially if you're using CI/CD, or if you're in an organization which is using many different technologies altogether. Potentially different microservices are written with different technologies. This is very standard because the only thing that you need to pass around is the project and a single Docker file, and no additional tooling dependent on that language is required. So this is quite a common approach, seen more, I think, in other technologies such as Golang. I see multi-stage builds used a lot in Golang projects, and other technologies as well. The reason why it may not be used so much in Java teams is because of the next approach, option 3, which we'll look at in a second. Okay, now we're moving on to option 3, using a Gib build. So Gib is a Gradle plugin, Gradle and Maven plugin. It can be used within the standard Java build process to take a Java project and build a Docker or container image directly out of it. It can be done even without having Docker installed on the build machine. So it's flexible in that way, sort of the opposite direction to option 2. And conceptually, for Java programmers at least, this is quite easy to get our heads around, because it's just using an extra plugin in the build process. So let's take a look at what that looks like in practice. So in this setup, I don't have any Docker file at all, and all I'm doing is building through Gradle. So to use Gib, I've included the Gib plugin, and then there's some Gib configuration. So basically, the base image that you want to base your application image on, and the name of the image that you want to create. I've also set the build target to depend on the Gib Docker build task. Now, this is a bit of a paradox, because I'm actually asking Gib to use Docker to build. You don't need to do that, but it takes additional configuration of Gib to connect to, say, Docker Hub or your artifact repository on Google Cloud or something similar on AWS. So I'm actually asking Gib to use Docker in this case, but Gib can run without Docker installed on the local machine. Run Gradle build. And so if we go, let's just check the Docker images that we have available at the moment. Multi-stage and simple from the last 2 examples, but we're trying to build something called Java Jedis Demo Gib. So we won't be running Docker this time. We'll be running Gradle wrapper, and then build. So it's built the application, and now it's running a Gib Docker build. Okay, it says it's successful. So let's look at the Docker images we have, and we have Gib, Java Jedis Demo Gib. Okay, then we get our white label error page for this service. That's how we use Gib to create a Docker image, and we'll just have a quick look at the trade-offs there. So it's a pretty smooth learning curve for Java developers. In fact, if you have a team and there's one person who's been responsible with setting up the build file, they could have set up that plugin and configured it, and the rest of the team just needs to carry on using Gradle build or pressing the button in their IDE, and there's no further issues required for them, no further learning required for them. It's also good because Docker or Podman are not needed. So again, this is great for enterprises who are suspicious about installing lots of different tools on people's machines. and and so the whole Docker image can be built without actually having Docker installed. It claims to achieve fairly fast builds. I think it was comparable with the other builds that I saw, but it does use smart layering, so we don't have the issue that we had with option 2 of, say, for example, downloading extra dependencies when the project changes. So as a disadvantages, not necessarily disadvantages, but for other developers, so if you have multi-technology teams, other developers obviously won't be using Jib, won't be using Gradle, they won't be so if you have say DevOps teams and they're not used to using Java tools but they're used to using Docker, then perhaps they will have a learning curve on that side. Obviously, if you're using this now, your build machines need to have Java tools actually installed on them. So that's an additional consideration. And there is some additional configuration if you want to like connect to Docker Hub or other image repositories. So that can be a bit fiddly to set up. And I avoided that in this case by using the Jib Docker build task. Okay, so that's all I have to say for these options. If you have better options or you have a different workflow, I'd be very glad to hear about it. So please message me in the comments, tell me what tips and tricks you have for building Docker images in your teams. Thank you very much.